Okay, we're back to the Sage material. And, each section of notes has sort of like Sage code that relates to what we've done. I'm not going to say it's a comprehensive treatment of everything, but probably enough to whet your appetite to say, I wonder if I can do more with this. And you can. Sage is a very extensible system. Now, of course, when you transfer, if you have me as a teacher at Essex and you transfer to NJIT, or even to another instructor at Essex County College, and you start talking about a computer algebra system, at Essex, they're probably going to say, no, you can't use it because we want you to do everything by hand. And then when you get to NJIT, they're going to say, oh, you can use it, but you have to use MATLAB, right? And you might say, oh, my teacher at Essex made me use Sage. And I got to be honest with you, there's no such truth to that. I did not make you use Sage. What I told you, which I hope you have this option in life too, you should use the tools that you find helpful, not because I told you to use them. Like if you don't find Sage helpful, you shouldn't be using Sage, but you need to find a tool set that's going to make your life a lot easier. All right. So I'm going to go back to Sage. So why do you promote Sage so much? It's free and it's widely used all over the world. That's why I promote it. All right. So I'm going to go back to my Sage thing and I'm going to clear my screen. And what I want to do is I'm looking at the code. I know I can type that in, but I want to go back to a problem that's perhaps more interesting. Every problem here is a problem from the set though. So I'm going to scroll back in the notes and I'm going to do number 9. Now I'm not reading 9. I'm just looking at the integration. So I'm going to reset. I'm going to set X to be a variable. Again, I'm not going to say you need to memorize everything. If you can't remember, scroll back, but integrate. I just hit tab there and I just put INT tab and I'm starting to realize it's got a lot of choice, doesn't it? So I'm looking for it. What do I want to do? Integrate. So I'm going to scroll down. You see what I'm doing? Whoops. I'm going to integrate. All right, what are we going to integrate? Star X star sine X. And I want to go from 0. Whoops, sorry about that. I want the X to go from 0 to 2 times pi. 2 star pi. I'll hit the return button. If you're doing this on CoCalc, it has to be shift return. Wow, minus 8 pi. Well, you know what? I want to get a numerical approximation to that. And I'll do that, see what happens. Let's hope it works. Okay, getting about minus 25 point something. Okay. When you go to NJIT and they give you in your first math course there, and the guy says, you have to use a computer algebra system. We have MATLAB for you, and they give you an account, and they tell you where the computers are and stuff. And I'm going to say it's an old-fashioned way of doing things, demanding that you need to use a particular piece of software to get some job done. You should be using the tools that you find helpful to get that job done. All right. Now, I will say there's one advantage to Sage over MATLAB. Sage is open source. You can look at the code. MATLAB, for the most part, is closed source. They do use open source software inside it, but it's really closed source, and you can't look at their code. If you're getting errors, you can't look at their code. Now, what I want to do is I want to use a commercial product, and I'm going to use Grapher. And I got this thing already graphed out. Someone says, what did you graph out? I graphed out 4 times X times sine X. And what I want to do is I want to integrate the problem between 0 and 2 pi. And 2 star pi and 0, right? And let's see. Ooh, it gives me a number immediately. You see that? It says it's minus 25. Let me just shoot back the Sage for you. Let me just do this. I'll calculate. All right. I like it. I'll tell you why I like it. I'm seeing a picture where they've actually shaded in the region. They shaded it in. They shaded that region in. Let me go back to that integration screen for you. And it was minus 25 25.1327. If you notice over here, they got a choice over here about different methods they want to use. I wouldn't worry about that. They also talk about tolerance, maximum number of iterations and order, things like that. Nothing for you to worry about this stage over here, right? These are numerical processes to compute that number. But you know, it's minus 25.1327. Let me go back to Sage. Whoops, I didn't mean to do that. Let me go back to Sage. And whatever again, minus 25.1327. All right. No shock there, right? Same number we're getting in using the grapher or the Sage. Here's the deal though. You need to start getting comfortable using software. The software that you decide to use is a decision that you decide to use. You probably want to use software that's compatible with other people's idea of what software should be. And that's the reason, another reason for Sage. I really can't think of any upper level institution that would not have Sage on their table, right? They might have other products like MATLAB and Mathematica and Wolfram Alpha. And really, there's a large number of applications out there to computer algebra, but get comfortable, all right? Will this translate Sage? Of course it will. Include if you get NJIT and you approach your teacher and say, you know what? I want to use Sage instead. They may actually be impressed. They may say, you're thinking outside the box. You're thinking. And they like that. I mean, some of these upper level teachers really like people that think. You may say, I'm going to use Sage. And they might say, go for it. You don't need to use MATLAB. MATLAB's a commercial product. Sage is open source, good for you. All right. So you have these options open to you. Thank you for listening.